So here's the project for tonight. I kind of feel like I can sympathize with the professional machinists that I hear complaining on Facebook sometimes, or I see complaining on Facebook sometimes about dealing with engineers. This drawing was given to me by a fellow who does most of the design work for the robots team that I'm the FIRST Robotics team that I volunteer with, and he's actually not an engineer. He's a graphic designer by trade, but he does most of the design work on the robots team. And this is a piece that we want to eventually have plasma cut by somebody, but there isn't enough time right now to get that arranged, and they want something they can play with tomorrow to start prototyping. So I got these big sheets of aluminum that he procured and these drawings to go by, and we're not going to worry too much about the pretty angles and all that sort of stuff and the cutouts and any of that. None of that matters. Just need mostly these holes to be fairly precisely located, and then these two holes to be precisely located, because this holds a motor, or this is a motor mount, and then this is a there's a spindle attachment here. I forget exactly. I think that's for yeah, there's going to be like a forklift coming off here, and this will hold the mechanism that drives the belt that's part of that whole thing. Anyway, so yeah, what's kind of the reason I said I sort of sympathize with the pros out there in their complaints about dealing with engineers is, first off, the guy didn't print this for me. He's shown it to me on his phone, and figured that we could just work off of that. And then he's like, yeah, some of these are in metric and some of these are in inches. I forgot to put down the measurements for some of these, and those are, oh yeah, by the way, that's a number 10s, those are number 8s, clearance for those, and just all this shooting from the hip kind of stuff. And I'm like, okay. I could imagine being driven nuts if this was your day-to-day job and you had somebody throwing that kind of crap at you. But he's he's a volunteer like we all are, and this is what he did, and this is what I'm gonna work off of. So here we go. Shouldn't be the biggest part for me for stuff like this, because it's a big piece, is just figuring out how to set it up on my mill. And unfortunately, I'm not going to do what he's thinking, that I would be able to just start with a hole here, and then using my digital readout, just work off of that and move everywhere I need to go. Because I did that in a smaller piece that we had when a previous robot we built, and I showed him how I did that, and he was like, "Oh, that's cool." But what he doesn't understand is this is too big. We're talking. Does it even have a measurement all the way across here? Well, let's just say it's going to be something like 1.5 feet by 2 feet. And my mill doesn't have that kind of travel to make that happen. And it's just going to be easier for knowing the tolerances that I need to achieve right here. It's just going to be easier to lay this out old school. I'm not going to use Dykem. I'm just going to use primer paint, and lay these all out. Punch holes, or not holes, but punch witness marks, and then come back and just drill all these using the mill. And the only hard part for me is going to be figuring out how to set up for, and this is going to be 2 plates that are going to be mirrors of each other. So I'm going to figure out how I'm going to hold the two together. And the only difficult part, this is supposed to be 1.25 inches, and this is 3/4. So I think the only way I have of achieving 1.25 inches is with boring, which is going to be weird with this sheet stuff. And I'm not sure how that's going to go. I wish I had some annular cutters. I think those would be great. I might have some regular old-fashioned hole saws, and I'm tempted to just use those if I can find one that's find a couple that are the appropriate size. I think they would do the trick for this. This isn't like holding bearings or anything like that. Anyway, so nothing exciting to watch, but I just thought I would share. This is what I had to start with. All right, just to grab some measurements, I blew up this part. My old eyeballs are too tired to quite read that. So, what did I do with my pencil? Let's grab one of these. To show you what I mean, these, as far as like, being mixed up between metric and whatnot, it's 0.9843. What he's really getting at is 25 millimeters, or the width of these extrusions that we use. So, 0.983, 25 millimeters. So I'm going to do a lot of conversions of that kind of crap. Just it's easier for me to have the real. And the 2.9. I mean, it doesn't need to be that precise for this particular application. That's 3 inches. I mean, I think all he was trying to do, he really wanted. These are to stack those extrusions. That's why these are like that. These here, I think these are probably pretty arbitrary. You just want them centered here, because this is going to go to a plate that's going to be made later, and it's just going to strengthen this whole joint here, because this is going to be a T that is going to be part of that whole forklift type mechanism I described. Anyway, so these are the kind of figurings I have to do here. Now, if I had a big table where I could just locate the center and just work off of that, fine, I would do every single daggone thing, but this is going to be a lot of scratching out. I went ahead and primed one of the sheets. I deburred all the edges, got my primer, and so I'm just going to start doing some layout. And I think I am going to start with the bottom corner. That is one measurement I can't figure out why it was chosen. 0.5896 doesn't really equate to anything that I'm aware of that we use. That's 15 millimeters. That's what it is. Why that is because I think this is meant to be flush with one of these, but the way he's drawn it, it's actually going to protrude a little bit. Again, I think it's a little arbitrary there, but I'll go ahead and do it 15 millimeters and start working from there. So yeah, I'm going to lay it out. Most critical thing is my T here, these, and these across. So as long as I get those right, and then from here locate that, and then that, I'm pretty much in business. The rest of it is all kind of arbitrary. But we'll see how it goes. You can see I'm starting to lay out my holes. And I just want to show this is how the primer works. It's been a long time since I actually had, you know, like the Dicom bluing stuff, I think like in shop class in high school or something. But this seems to work pretty well. You know, it's pretty good. So my latest development, I'm sitting here walking up each of these hole measurements along my line here. I'm like, wait a second, I'm running out of room. So I'm add it all together, and I need 19 inches just from center to center here on these holes, and then all the way across here I need 22 inches, I think it is. And this plate is 16 by 20. So I call up the illustrious designer. He's like, oh yeah, we just need the critical parts, so just fit, you know. And basically he just wanted this. As long as this fits on it, we're good. I can't work in these conditions. Yes, I'm basically using the mill as a very expensive drill press right now. It makes a pretty nice drill press. I think this is the first time I found a good use for my little mini cant twist clamps. Little teeny jokers. But they're perfect for this job. So this was the one hole I didn't have the bit large enough for. It's got to be 1.25. I drilled it out to 1, and so now I'm boring it out the extra 1/4 inch. It's going to take a good while at that rate. I'll do that a few more times and I should be done. Oh darn, am I reaching the limit of travel for this thing? I wouldn't think so. Oh yeah, I think actually this thing is meant to go the other way. That would make sense actually. Alright, I gotta reset my... I redo my setup here. This boring bar should be in this hole over here facing out that way. That way, when I... Can you see these gradations there? One second. Yeah, this makes more sense. So these are thousandths, and it makes sense actually that as I want to increase the size of the hole, I would be turning this way. So that's adding 10 thousandths to the bore. Yeah, okay. Alright, I know what I did wrong. Alright, here we go again. There we go. That's a nice clean bore. And it should be 1.175. Let's see what we got. Pretty damn close. I should take it to 1.225. You know what I really wish I had right now was some annular cutters. Those would be great. Maybe I'll ask for those for Christmas this year. I've seen a setup on Amazon for about $100. You get the cutters and the R8 adapter. Let's see if I figure that out right. Yep. 1.225. So now we want to bring this out 25 thousandths. And I'm just going for it. I'm not going to sneak up on it or anything. I don't think the tolerances in this application are that tight. And I got to take the backlash out. 1.25 inches. That's what I needed. I am done. Alright, so here's where I ended up for the night. Now bear in mind that we're going to get this piece made by somebody with a, a sheet metal fab place that'll plasma cut it, and it'll all be hunky-dory. But this is just so that tomorrow they will have something that can mock up the, well, they won't mock, it'll prototype the lift mechanism for this robot we're building. So you've got your structural, cross pieces here, and then the plate here where it's joined in to the frame itself, and most importantly, motor mount, chain drive here, and then there will be a spindle that carries a tape basically that runs and lifts the forklift mechanism up and down. So unfortunately I have to work tomorrow, so I won't get to see them put it together, but I hope I'll get some pictures of it later. It'll be a temporary thing. They'll tear it all apart later when they get the real one, but it should keep the kids busy tomorrow, so that's the main thing. Alright.